Namaste and a very good evening to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about how to build a logistic regression model using Python. Even before I proceed to demonstrate how to build a logistic regression model using Python, may I request you to subscribe to my channel, also like and share my videos. Let's begin by asking a simple question as to what is a logistic regression model. The answer for this question is as follows. A logistic regression model is a supervised machine learning technique. In the case of a logistic regression model, we have a dependent variable. It is typically used as a classification model. Suppose you are working for a bank and you want to build a model which classifies the customers as high risk and low risk. You're effectively predicting the credit worthiness of an individual. Since the outcome of interest is binary, we can go ahead and build a logistic regression model. Let's take another example of telecom sector. In a typical telecommunication sector, we may be interested in predicting whether a customer will churn or not churn. Here again, since the dependent variable is dichotomous in nature, we can again go ahead and build a logistic regression model. There are two types of logistic regression models. One is what is called as a binary logistic regression model, and the other is a multinomial logistic regression model. As the name itself suggests, in the case of a binary logistic regression model, the dependent variable is binary or it has binary outcomes. In the case of multinomial logistic regression model, we have a categorical dependent variable which has more than two outcomes. Compare this with a linear regression model. Typically, in a linear regression model, we have a scale dependent variable. On the other hand, in the case of a logistic regression model, we have a categorical dependent variable. Thirdly, in the case of linear regression, we use an algorithm which is called as OLS or ordinary least squares. Here, in the case of logistic regression model, we use what is called as MLE or maximum likelihood estimation. MLE is a technique which is used for parameter estimation. Fourthly, in the case of linear regression, the relationship between the dependent and the independent variable is described by a straight line. However, in the case of a logistic regression model, the relationship between dependent and independent is described using a sigmoid function. With this background about logistic regression, let me quickly introduce you to the data set that I'll be working on. This is the very popular iris data set. There are 6 columns in this data set. You have important flower characteristics like sepal length, sepal width, petal length, and petal width. The last variable that I have is the species of flower. I'm going to use species as the target variable and the flower characteristics as the independent variables. Sepal length, sepal width, petal length, and petal width are my independent variables. Let's understand the first record. The first record represents a flower whose sepal length is 5.1 centimeters. Its sepal width is 3.5 centimeters. The petal length is 1.4 centimeters and the petal width is 0.2 centimeters. What is the sample size in this data set? The sample size in this data set is 150. So we have a healthy sample size to build a logistic regression model. Let me now apply a simple filter. I'm interested in looking at the number of classes that we have in the target variable. When I click on the drop-down menu, you see 3 different classes. First is setosa, then you have versicolor, and lastly, you have virginica. So this is what is called as a multi-class problem. Now, I'll be proceeding to Python. In Python, we will see how to operationalize a logistic regression model. As you can see here, this is Jupyter Notebook. I will quickly run through some of the important codes that can be used to run the logistic regression model. In the first step, what I'm doing is I'm importing the required libraries. Primarily, we'll be needing the NumPy package. We'll also be needing pandas. NumPy is used to perform numerical operations, and pandas is useful when it comes to data munging and data wrangling. I will need a data set to execute a logistic regression model. We have what is called as sklearn or what is called as scikit-learn. Now, this is a very popular library which is used to perform machine learning tasks. Here, sklearn.datasets will be used to import load_iris. I can easily load the iris dataset from the sklearn library. Further, I'm also importing the logistic regression function and the train test function. To evaluate the overall performance of the model, we can use certain important data science metrics like accuracy score, precision score, recall, and F1 score. The first step is all about importing the necessary libraries. In the second step, what I'll be doing is I will be loading the iris dataset and I'll be saving it as an object which is called as iris object. In the third line, what I'll be doing is I will be converting the data set into a pandas data frame. What is a pandas data frame? A pandas data frame will give you a spreadsheet-like view. It becomes very easy to visualize the data set. We can easily comprehend the columns and the values that are stored in the column. If we go ahead and execute df.head of, you can now see Python displays 5 records and the individual column names, namely sepal length, sepal width, petal length, petal width, and we have the target column here. This is very, very easy to visualize when you convert a data set into a pandas data frame. In the next stage, what am I doing? In the next stage, as you can see here, I'm splitting the data set into training and test. How do we do this? You can use the train_test_split functionality. Once you use this particular functionality, you can specify what is the size of the test data set. I will be using 60% for test and 40% for training. You can experiment with different numbers here. There is no hard and fast rule that you have to select only 70 and 30. I've experimented with 70% for training. I've also experimented with 80%. Sometimes you can go ahead and use 90% as well. You can specify the random state as 42. When you go ahead and execute this, you will be creating 4 objects. The first is x_train. X_train is an object which will contain all the independent variables which we will be needing for training the dataset. X_test will have all the 4 independent variables which will be used for testing the dataset. Similarly, we have ytrain and ytest. Ytrain and ytest are nothing but the dependent variables that are present in the training dataset and the testing dataset respectively. Next, what we will be doing is we will be initializing a logistic regression model. You can see here, this is the function that I will be calling logistic regression, and I'll be specifying LBFGS as the value for the solver option. You can experiment with the maximum number of iterations. Here I've specified the maximum number of iterations as 10,000. Sometimes the solution does not converge within 10,000 steps. When I went by the default option of max iteration, the solution did not converge, and hence I have experimented and given it a higher value. Let me go ahead and initialize the logistic regression model. Next, what we will be doing is we will be using X-train and Y-train to fit the logistic regression model. Remember, when it comes to fitting the model is fitted on the training data set. However, after fitting the model on the training data set, you can go ahead and apply the model on the testing data set, which is what we are doing, logreg.predict. Here we are passing an object which is called as x_test, which means we will be using the independent variables which are present in x_test to generate the predictions, and those predictions are saved as y_pred. I've executed this particular model. Now, let us evaluate the overall performance of the model. The evaluation metrics that we are interested in would be accuracy score, precision, recall, and F1 score. Firstly, accuracy. This is something which is popularly used, which tells me the overall quality of the model. All of these metrics will lie between 0 and 1. If the accuracy metric is close to 1, it means that our model is good. On the other hand, if any of these accuracy measures are close to 0, it means that we have a poor model, in which case we might want to experiment with the hyperparameters of the model or look at some of the other models like a support vector machine or a neural network model, or sometimes people also experiment with boosting or random forest model. This is accuracy score, which is slightly simplistic. It does not embrace the complexity that is needed while evaluating the overall performance of the model. And therefore, we have another interesting metric which is called as the precision score. How do you evaluate the precision score? We are going to use a simple formula, which is precision equals true positives divided by true positives plus false positives. I repeat, precision score can be evaluated as the ratio of true positives to that of the sum of true positives and false positives, which simply means that out of the total predicted values by the logistic regression model, how many has it got it right? Logistic regression model may have predicted a lot of cases as positive. The question is, out of the total predicted positives, how many has the logistic regression model got correct? This is indicated by a precision metric. Precision as a metric lies between 0 and 1. If the precision value is close to 1, if it is greater than 70%, then it's an acceptable number. If the precision is close to 1, it means that we have fewer false positives. There's an inverse relationship between precision and false positives. If the false positives go up, precision would go down. On the other hand, if the false positives go down, the precision would go up. So this is how, by using precision, what we are doing is we are penalizing a model. We are punishing a model for having high false positives. The moment you have high false positives, precision will go down. When you get a low precision score for your model, it's a clear indication that you have a high false positive. The next interesting metric that we would look at is what is called as the recall score. What is the recall score? Recall score is simply the ratio of true positives to that of true positives plus false negatives. It's the ratio of true positives to that of true positives and false negatives. What does this mean? Out of the total number of actual positives, how many has the logistic regression model got it right? I repeat, out of the actual number of cases which are positive, how many has the logistic regression model got it right? You can loosely call this as the hit rate. Here, in the case of recall has an inverse relationship with that of false negatives, which simply means that if your recall value is low, it indicates a high false negative rate. On the other hand, if the false negative rate is very low, it means that we have a high recall value. Last but not the least, we have F1 score. F1 score is simply the harmonic mean between the precision and recall. How do you calculate the F1 score? F1 score is simply 2 times precision multiplied by recall divided by precision plus recall. This is how we can use the F1 score. Popularly, F1 score is used whenever we have a class imbalance problem. So whether it is accuracy or precision or recall or F1 score, all of these values will lie between 0 and 1. A value which is greater than 70% is an acceptable number. Let me go ahead and calculate some of these model quality indices. Lastly, we have the evaluation metric. When I ask Python to print accuracy, precision, recall, and F1 score, you can see here Python displays the accuracy metric as 97%, which is on the higher side. Then we have the precision value as 97.9. Then we have the recall value, which is again around 97%, and the F1 score is 97%. A high value for accuracy, precision, recall, and F1 score indicates that the model is a good model. Once we have come to the conclusion that the model is good, we can go ahead and deploy this model. Remember, in the deployment stage, what we do is we operationalize this and put this in a production environment. With this, I have come to the end of today's video. To give you a high-level summary of what we did today, we looked at what exactly is a logistic regression model, what are the important features of a logistic regression model. Then we imported certain libraries in Python. We created a train test split. We split the data set into 2 parts. We built the model on the training data set. We applied its result on the testing data set. Further, to evaluate the performance of the model, we use certain model KPIs, model performance KPIs like accuracy, precision, recall, and F1 score. With this, I have come to the end of today's video. In today's video, we have seen about logistic regression model. I request you to subscribe to my channel, also like and share my videos. Thank you very much for watching this particular video. Have a great day ahead.